Now we can also use implicit differentiation to find the derivatives of the log functions, which we've done for the natural log. Actually, I don't think we have. I don't think we've done any of these yet. Okay, so let's just do a general log base a first. So if I have the function y equals log of x base a, I can also write that equivalently as a to the y equals x. And we have done the derivative of exponential functions. So I'm going to take the a to the y equals x, and I'm going to use implicit differentiation, and I'm going to take the derivative of both sides, and my goal is to find dy dx. So I take the derivative with respect to x of each side, and on the left-hand side, again, we've used our found our shortcut rules for the log function already. The derivative of a to the y with respect to x is rewrite the exponential a to the y times the natural log of the base times the derivative of the exponent. Again, y is a function of x. And on the right-hand side, the derivative of x is just 1. So now I want to solve this for dy dx. That is, I'm going to divide both sides by a to the y times the ln of a. But then I'm going to remember that a to the y is x. That's where I started at the top. So I have 1 over x times the natural log of a. Okay, so that means that the derivative with respect to x of the log of x base a is 1 over x times the natural log of a. So make sure you realize the natural log of a is part of the denominator there. Now, if I look specifically at the natural log function, which comes up a lot, right? That's a common base, is base e for the natural log function. I can run through the same process. If y equals the natural log of x, then that means e to the y equals x. And I can do the same thing that I just did, but using specifically base e instead of generic base a, and see what happens. So once again, using implicit differentiation, I'm going to take the derivative of both sides with respect to x. And on the left-hand side, the derivative of e to the y with respect to x is e to the y, technically times the natural log of e, but I don't have to write that because I know the ln of e is 1. But the chain rule says I have to also multiply by the derivative of that exponent, dy dx. Of course, on the right-hand side, the derivative of x with respect to x is just 1. So now, to find dy dx, I divide both sides by e to the y. But if I look back at the top where I started here, e to the y is equal to x. So I can write that as 1 over x. So that means that specifically when the base on the logarithm is e, if I take the derivative of ln of x with respect to x, that is in fact 1 over x. So these rules are found in section 3.7, and we were able to use implicit differentiation to figure them out.